Okay, hello everyone. My name is Mete Atamel. I am a developer advocate at Google, and in today's first talk of the conference, I want to talk to you about open standards for building event-driven applications in the cloud. Before I start, I already have the slides on speaker deck, so if you want to grab the slides, this is the link, and I'll share another presentation as well. And if you want to hear from me, this is my Twitter and my blog, so feel free to follow me as well. All right, first let's do a little bit of introduction. And let's take a look at a very simple example of an event-driven architecture so that we understand what event-driven is. And then after that, we'll get into some standards in this space. So let's imagine you have an order processing system. And let's also imagine that you built the system using an event-driven architecture. This is very simplified. Of course, in a real-world application, you have much more complicated order processing systems. But just to show you the basics, let's say you have a front end receiving requests from the users. Then when the front end is done, it will submit a message or order received message to a message broker or event bus. And then the message broker will look at this message and it will figure out that the payment processor is interested in this order received messages. So it will route that message to the payment processor. Then the payment processor will do its payment processing. Then when it's done, it will emit another message, this time payment process message. And again, this goes to the message broker. The message broker figures out who's interested in this message and routes that to the shipper and so on and so forth. So this is a very simplified event-driven architecture. But the key point here is that these services are independent. They don't know about each other. They don't call each other directly. They just communicate indirectly using different events. And message broker is the one kind of orchestrating this and figuring out what event needs to go where, okay? Now, in this event-driven architecture, you need to decide and communicate a couple of things. The first thing that you need to decide is the envelope of the events. So these events I showed you, the order processed, payment process events, they all have their envelope, like the format of the event. So you need to decide on that upfront so that the services know how to receive and read these messages, and they also know how to submit these messages. And the second thing that you need to decide on is that you need to figure out a way to, well, first of all, decide on which service publishes what event types and which service subscribes to what event types. So you need to decide on that, and you'll also need to find a way to communicate that so that others who want to consume these events or others who want to publish these events, they know how to do it, right? So the TLDR of this talk is basically CloudEvents defines an envelope for events that you can use. And AsyncAPI helps to document the event formats. So not just the envelope of the event, but also the data of the event. And AsyncAPI also helps you to document which service publishes or subscribes to what events, right? So this is basically my talk, and we're going to talk about what CloudEvents is and what AsyncAPI is and how they help you with these things. But basically, that's what these two projects are about. Now let's look into CloudEvents first and see what it provides for us. Now, first of all, before looking into any type of technology, it's important to ask the question of why. Like, why should we even care about this technology? And in this case, why should we even care about CloudEvents? So let's imagine we have another event-driven kind of architecture where we have different event sources publishing events. And these events, usually they end up in a middleware where you see these events, maybe you do some processing, and then eventually you send them to event destinations, different event destinations, right? So in this scenario, let's also imagine that these event sources are publishing events in different formats. So maybe one event source is publishing events to Kafka, another one is an IoT kind of event source, so it's publishing to is publishing using MQTT. Then maybe another event source is using Google Cloud's PubSub. So they're different event formats. So in this scenario, all of a sudden your middleware gets quite complicated because you have different protocols. So Kafka, PubSub, and others. You have different event. You can potentially have different event formats. So typically people use JSON for event format, but maybe you want to use something more efficient like Protobuf or Avro. And depending on what you're using, you probably have different event schemas as well, right? So different protocols, different formats, different schemas. And all of a sudden, reading these events become difficult because now your middleware and also your event destinations, they need to understand these different formats and use potential different SDKs and everything to read them. And also middleware has to figure out how to route these events. It needs to probably look into these events, read them, and get that routing information so they can route to the right destination. So CloudEvent tries to simplify this basically so that you don't have to deal with all these different formats and protocols and SDKs to read and write events. So what is CloudEvent? It's an open source specification. So it's first and foremost, it's a specification for describing events in a common way. So that's a very clear goal. And I like when projects have a very clear goal. So it's about describing events in a common way. And it's also SDKs to read and write those CloudEvents. So it's not just a specification, but they also provide SDKs to kind of read and write these CloudEvents. It defines a minimal set of what's called context attributes. And these context attributes, they basically help to route these events. And we'll look at an example in the next slide. And whatever data you have that's not part of this routing information, it's placed within this data field of the event. So your custom payload, for example, basically lives in this data field. You can also have this data base64 field if it's base64 encoded data. So let's take a look at how CloudEvent looks like. Well, CloudEvent has a couple of different, well, actually 3 different modes. We'll look at 2 modes here right now. And the first mode is called binary mode. And binary mode, it's good for receivers. It's good for event receivers who are not aware of CloudEvents, right? So if you have a receiver who's not aware of CloudEvents, then they can kind of ignore this metadata if it's in binary mode. And I'll show you an example and I'll show you what I mean by that. So this is I'm using here a curl to send a CloudEvent in binary mode. So you see, this is the CloudEvent. And a couple of things to point out here is that first of all, the content type defines the mode. So this basically says it's a JSON content type, and in this case, this means this is binary mode. Then we have some required fields of CloudEvents. So this CE dash is the headers for CloudEvent, and the spec version type, source, and ID is the required fields that you have to set. The important part is first of all, which spec you're using, because CloudEvent have a few different versions. The type of the event, the source of the event, and the unique ID of the event that you have to provide. Then the rest is optional, but it's good to provide them, like the time and the subject and so on and so forth. Then you have what's called extension attributes. The extension attributes, they are custom attributes that you can set for your own application. So that's the way you can extend a CloudEvent. And finally, you have the data, the payload. In this case, the payload is in the body of the CloudEvent. So as you see, in binary mode, the CloudEvent attributes are headers. So if a receiver, they don't understand CloudEvent, they can just ignore these, and the payload is still there. So it will still work in that sense. So that's what binary mode is good for receivers unaware of CloudEvents. Now, the other mode of CloudEvent is called structured mode. And structured mode is for simple forwarding of events across multiple routing hops. And again, let me show you the example before this makes sense. So this is the same event, but it's sent in structured mode. One thing that you'll realize is that there's no headers right now. So we are not sending any headers except the content type. So again, the content type defines the mode. So here we are saying CloudEvents plus JSON. So this basically says this is in CloudEvents in structured mode. Then we have the required fields of CloudEvents, and these are just regular. They're just this is just regular JSON in the body of the event, right? So this is the required fields. Then we have the extension attributes, and then the actual payload lives under data field, because the body includes like the whole cloud event. Yeah, so as you see, everything is included in the body, and this allows you to send cloud events across different places, basically, because it's the body like that has all the information. So the receiver doesn't really need to look at headers or anything like that. It just needs to forward the message as it receives, and this allows easier routing across different multiple hops. All right, so what else cloud events provide? Well, it provides different event formats. So you can have events in JSON, and JSON is the one that's most supported, but you can have protobuf, Avro, and XML, which is in draft. It's not implemented yet. So you have choice in different formats. You have protocol bindings. So this is about how the event goes over the wire. So you can send events over HTTP, but you can use things like AMQP, Kafka, MQTT, and even WebSockets is in draft right now. Again, this allows you gives you choice basically on how to send events with different formats. And then you have SDKs on different languages. So these are the supported languages right now. And finally, there are cloud event libraries from different vendors. For example, Google Cloud. If you look at Google Cloud, this link, it shows you what kind of Google Cloud events are published in cloud events. And it also gives you libraries to read those events, because you can use Cloud Events SDK to read the envelope of cloud events. But then you can use these Google Cloud libraries to read the data field of those cloud events, because the data field is the one that has all the Google Cloud specific data. And you can look at those details on my GitHub that I have here. So that's all good, but you need to also know some limitations. There is a batch mode in cloud events where you batch multiple events in a single message, but not all protocol and SDK combinations support it. For example, the JavaScript, well, I should say Node.js SDK supports HTTP and Kafka batch mode, but it doesn't support, for example, MQTT batch mode. So you need to, if you want to use batch mode, you need to check whether it's supported in the language that you want. Not all event formats are supported in each SDK. Just to give another example, JavaScript SDK supports JSON, but it doesn't support Avro or protobuf. So again, you need to check the language SDK before you use the event format that you want to use. Not all protocol bindings are supported in each SDK either. So the JavaScript SDK supports HTTP and Kafka, but not AMQP, QP, MQTT, NATS, and so on and so forth. So again, you need to check before you say, okay, I want to use this language, this protocol binding, and this event format. So you need to keep these in mind. All right. And then finally, in cloud events, there's some upcoming specs. So there's Discovery API about how to discover these events. Then subscription API on how to subscribe to these events, and a registry, schema registry, so that you can learn how these events should look like. So as you see, cloud events is also kind of changing and expanding beyond the envelope of the events and more about the life cycle of events, right? So once you define the envelope, you need to think about, okay, how do I communicate this envelope to different people? So that's what you would use a schema registry for. And then once people know these events, if they want to discover them or subscribe to them, then there will be APIs for that. I haven't played with this yet because they're proposals, but once they come out, I will try and see what they provide. All right. And finally, there's a lot of support of cloud events from different providers. Google Cloud Event Arc publishes cloud events. Azure Event Grid, Adobe I/O events, and Knative open source project supports cloud events. So there's a lot of support of cloud events in open source and also in cloud providers as well. All right, so at the beginning of the presentation, I said, in event-driven architectures, you need to decide and communicate the envelope of the events. So cloud events give you an envelope that you can use, and there's good reasons to go with that. Hopefully, I convince you of that. But you still need to decide on how you're going to decide which service publishes or subscribe to what events, and how do you communicate that as well, okay? And that's when the Async API comes into the picture. So let's talk about the Async API next. What is Async API? It's, again, another open source specification to define an async API, similar to what OpenAPI does for REST APIs. So if for those of you who know about OpenAPI, it's a way to document your REST APIs, right? So Async API tries to do the same for asynchronous APIs. So not REST-based APIs, but event-driven asynchronous APIs. So it's a specification, but again, it's more than a specification. It also provides tools to visualize and validate these Async API definitions. So this is very useful to kind of see your architecture using these tools, and I'm going to show you an example. And it also gives you generators to generate code from the definitions of Async API. So what you can do is that you can create your definition of Async API definition of your services, and then use generators to generate code to kind of subscribe to those services or to publish to those services or topics, I should say. So it's specification, tools, and generators. Basically, those are the three main things of Async API. There are some concepts in Async API that you need to understand, and these concepts are, application, server, channel, protocol, producer, consumer, message, and bindings. Let's actually take a look at these quickly on my GitHub. I explained them in more detail on my GitHub. So at the top level, you define an application. This is basically what your application is about, and this is what for example, in your order processing system, you would define that as an application at the top level with information. Then once you have your application defined, you need to define your server, because that's where you want to send messages to. So the server will be a Google Cloud server or Apache Kafka server, and so on and so forth. Then within the server, you will have one or more channels to publish events to or receive events from. Typically, this maps to a topic or queue or path or something like that. Then once you have the channel, you need to define what protocol the channel uses, such as AMQP, HTTP, WebSocket. And then once you have that, you kind of have the basics, right? You have the application, you have the server, you have the channel, you have the protocol. Then you need producers and consumers to send messages and receive messages. So you have producer or publisher, or a consumer or a subscriber to send and receive messages. And then you need to define what these messages are. So what the format of the messages are, how they look like, the kind of the schema of the message. And finally, you have what's called bindings. Binding allows you to extend Async API for different protocols. So there's bindings for servers, binding for channel, operation, and messaging. So you define them under each section. And then these allow you to specify protocol-specific things. For example, if you are using Google Cloud, there's Google Cloud server binding, there's Google Cloud channel binding, so on and so forth, right? So these are the main concepts in Async API. And if we compare to OpenAPI, so in OpenAPI, this is for REST endpoints. You typically start defining your application and your servers. Then you define what's called paths, because REST APIs are path-driven. And in the path, you specify the operation or HTTP operation typically, which is get, put, post, so on and so forth. And then in the component section, you define what's common between these requests and responses. So the responses, response headers, so on and so forth. So Async API tries to do similar things, but slightly different, because we are dealing with messages instead of paths. So we still have the info and the servers, but instead of paths, we have channels. Then instead of operations like HTTP operations, we have publish and subscribe operations. And then you have messages that you define, and other components you kind of define the common things within your messages, like the schema of the message and the bindings and so on and so forth. So that's the quick comparison of OpenAPI and Async API. Now, what does an Async API definition look like? So this is the minimal async API definition that you can have that works with the validator of async API. But basically here we are saying that we are using the latest version of async API 2.6. Then this is the application information. This is our hello world application, and we can give it a version. And we are defining a single channel. I mean, typically you will have a server and multiple channels, but the minimal definition allows you to define a single channel. And this channel is called hello. And then it has a single operation called publish. And this publish, which means you can publish to this channel. And the message you can publish is defined here. This message has a payload that has a type string. So this basically means you can publish this channel with a message that has the type string. So you can just basically send a string to this channel, right? So this is the simplest async API definition possible. If you look at another one, again, I will refer you to my GitHub. So this is a slightly more complicated async API and slightly more realistic, is that we define our application here, then we define a server. So here we are defining an AMQP server. So you see you will define the URL of your server, then the protocol, and a little bit of description. Then here we define multiple channels. So there's two channels, the hello channel and the goodbye channel. And in hello channel, you have a publish operation, meaning you can publish to this channel. And the message that you can publish is defined under components messages hello message. So we'll look at that later. Similarly, the goodbye channel has a message, but this time the message is goodbye message that we define here, right? Then under components, we define our messages. The hello message has a payload of object, so it's an object. And then the properties of that object is first the name, which is a string, and then send at, which is defined further down. Similarly, the goodbye message is an object type, and it doesn't have a name. It just have a send at field that's defined here. And under schemas, if you look at send at, we see that this is a type string, and the format of that string is datetime. So you see how you define servers, channels, and messages of those channels, and how you can kind of combine them and combine things that you use. For example, here the send at field of the message is common, so we put that under components and the schemas, and how you can share things, right? So that's how an async definition API looks like. And I already mentioned this, but in async API, there's publish and subscribe operations that you can have under channel. These can be confusing depending on where you're looking from. So, for example, if you are thinking, so if you look at the publish term in async API, from server's perspective, this means the server receives the message. But from the user perspective, it means the user publishes or sends the message to the server, right? And in WebSocket, for example, this is more like a send in WebSocket. On the other hand, if you look at the subscribe term in async API, from user's perspective, this means the user subscribes or receives messages from the server, where from the server perspective, it means the server publishes the message, right? And again, in WebSocket term, this is more like a receive. So this can be confusing. My recommendation is that think of it from this user perspective, because this matches more with the async API term. This is most useful. And if you go to this link, I show you a sample example and how to take that and how to convert it into publish and subscribe terms of async API. And async API, as I mentioned, it's not just spec, but it's also tools. So there's Async Studio, which is a browser-based tool to author and visualize and validate async API files. And there's a CLI where you can create async API definitions, and you can validate them. And then there's a generator project where you can create code from your definitions. And actually, let me show you the Async Studio. This is because this is very useful. So here, for example, I have some definition of Google Cloud PubSub definition. And then in Async Studio, I can actually see the operations here, the servers, the operations, and I can even get examples if I click, maybe not here, but yeah, but you get a nice visualization of your channels and operations and things. So that's what Async Studio does, and it also validates your Async API here. Another thing I want to look into is, well, maybe CLI I show you later, but if you look at generator project, you can see that there's generators for different languages, Node.js, Java, Java Spring, Go, .NET, so on and so forth. They work, but my experience is that they are very limited on what they do. So, not all combinations of async API definition is supported in all languages. They do like a very small subset of the full definition, which is understandable because async API is really diverse. So it's hard to support all the combinations in all of the languages, but it's a good starting point if you want to kind of generate some code and take a look at it. And then I have this quick start where I show you how to install the Async API CLI, which is Node.js based tool, I think. And then once you install the generator, then you can do Async API new and create a definition, an example basically. And once you create an example, which basically creates this YAML file, Streetlights API example, then from there, what you can do is you can look at that visualization in Async Studio. So you'll see what's supported in visually. But then you can do validation. So Async API validate to this YAML. And you can also generate code. So if you do Async API generate, point to your YAML and point to the template, then this generates code for you. And if you wanted to look at the code, I already have it here generated. But basically, it's a Node.js app. And you can see, it's a Node.js app that can listen for messages and send for messages. So you can take a look if you like. So it's a good starting point if you want to quickly test your Async API definition and send messages to it and see how it works. Unfortunately, I'm running out of time, so I won't have time to show you that, but feel free to check it out in this link. Okay, so going back to our question, in event-driven architectures, you need to decide and communicate the envelope of the events. So we can do that with CloudEvents. And you need to also decide on which service publishes or subscribes to what events. So you can decide that and document that using Async API. So I think we are covered in both cases. And in the last 2 minutes, I also want to show you how extensible Async API is. So I talked about CloudEvents and I talked about Async API. And I also talked about PubSub, Google Cloud PubSub, and Async API. So one question that you can have is that, can I use CloudEvent and Async API together? And the answer is yes. And I show you an example of this. So for example, if we have CloudEvents in structured mode, then you can define an Async API definition. And the key thing here is that in the schema, you point to CloudEvents schema, basically, which is great. So basically, we are using CloudEvents schema within Async API, and that works. And then if you are using the binary mode where you have the headers, you can define what's called traits, message traits. So message traits, you can think of them as snippets of code that you can reuse. And this will basically says every message will have these headers. So we are defining CloudEvents headers here. And then in your structured, you can just point to your, in your binary, you can point to your message traits. Here I'm pointing my message traits, and that's how we can use CloudEvents. And similarly, if you want to use PubSub and Async API together, you can do that. And I show you an example here. This is because Async API has Google Cloud PubSub bindings that was implemented by an engineer at Google. And with that, you can support PubSub as well. All right, I think I'm almost out of time. So hopefully this was useful to you using CloudEvents and Async API. But as I mentioned, Speaker Deck is where my slides are. And if you want to learn more about Cloud Events, these are the official links, Cloud Events and AsyncAPI. But I also, everything I talked about, I have them on GitHub at Cloud Events Basics and AsyncAPI Basics. Thanks very much for listening, and enjoy the rest of the conference. Thank you.